Hello viewers, greetings of the day. Today I am going to discuss about the OSI versus TCP IP reference model, the comparison of OSI and TCP IP network models in computer networks. I am Dr. P. Ramadevi from Institute of Aeronautical Engineering. Let us start. So, there are in the previous session we have discussed about the OSI and the TCP IP protocol suite. OSI is the reference model. It is a network model, and TCP IP also it is also a network reference models. They are. So let us see what are all the differences between, or what are all the differences between OSI versus the TCP IP protocols. Open system interconnection versus the transmission control protocol, internet protocol slash TCP transmission control protocol slash the internet protocol. So first of all, let us discuss what is TCP IP, what we have come across. So we have discussed earlier that TCP is a transmission control protocol slash internet protocol. Then it is developed by DARPA. So it is developed by DARPA. No official protocol standard is as there is no official standard for the DARPA. So they can identify 5 layers. So this is not there. The TCP IP protocol difference between OSI reference model and the TCP IP protocol suite is this is there is no official protocol standard for the TCP IP. So it can identify 5 layers. So this is identified as some books gives a 5 layer approach. Some book gives the 4 layer approach. Previous session we have discussed the 4 layer approach. Now here the difference between the previous session and what we discussed and the now is the here. We have seen the as the physical layer and the data link layer together. We have specified as as a link layer, but here a physical layer separately shown, and then network access layer as shown as the network access layer, and then internet layer, then host to host. It is nothing but host to host. Another name for the transport protocol is the host to host layer, and then another one is the application layer. So this is another. This will give the 5 layer approach of TCP IP. OSI view of TCP IP. So let us see what is the OSI view of the OSI model. We have studied that, as you see here. Here we have the 7 layer approach. It is a OSI layer. OSI model is a 7 layer model. That is, it has physical layer, data link layer, and the data link layer it operates with the help of the protocol HDLC protocol. Then high level data link control. It operates in with the help of this protocol. And this one is the network layer, transport layer, session layer, presentation layer, 6th layer, 7th layer is the application layer. So here this is compared with that of the 2 layers. That is the this one is the internet model. Internet model. What are the internet model? It is a this one is the physical layer, network layer. Network layer consists of IPv4 version, internet protocol version 4, then or internet protocol version 6. So version 6 is the advanced version of the internet protocol version 4. Then another the layer is another. It is split into the internet, and the another layer. This one is the transport layer. Transport layer consists of the 2 protocols, that is transmission control protocol and the user datagram protocol. The next one is the application layer. In the application layer, what different protocols we have just come across. That one is HTTP, Telnet, SNMP, SMTP, NFS, and then FTP. All FTP protocols, all these are file transfer protocols. All these comes under the application layer. So this is an internet model. The OSI layer, there as we have discussed, it is a 7-layer approach, and this one is the another model is FD's model. That one is the 4-layer model. This one, what is this one? We have the physical layer, data link layer, network layer, and the application layer. So different different the layers, different book speaks different layers. OSI versus the TCP layer continues. So here, as you see here, whenever if it is a this one here, we have the 5-layer approach. So in this 5-layer approach, what we are discussing is here the in the 5-layer approach, as you see here, physical layer is there, data link layer is there, network layer is there. If you compare with the TCP, if you compare with the TCP IP protocol suite with that of the OSI. Here the session layer and the presentation layer is merged, and then it is treated as the one single layer, that is transport layer. Then the final one is the application layer. So this is a 5-layer approach. Here this one, so how the communication takes place here is in the physical layer, the whatever the signal message, whatever the message is there, whatever the information is there, that info, suppose we says hello. So all hello is converted into the converted with the help of the machine internal hardware. It is converted into a signal. The ones and zeros, it is converted in the form of a signal. That so the here, so whenever a sender wants to so like that, this signal is represented here. So first of all, we'll start the at the sending end, as we have discussed already, that the from the sender, from the process starts from the application layer. So from the application layer, using the hypertext transfer protocol HTTP, a request is sent for the communication. So when a request is sent as a communication, the transport layer will have the host-to-host communication. So what it does is the whatever the request is there, so it will have the with the help of a transmission control protocol, the request is sent to the network layer. So when it is sent to the network layer, it is for the transport layer. Network layer is the lower layer. So after that one, when the message is sent with the TCP protocol, with the help of TCP protocol, it is sent to the host to host. So in the network layer, the message is here in the network layer, the IP address is added here. Internet protocol address is added here with the information of TCP, HTTP request. So it is added. The IP information is added. So this is a packet. We call it as protocol data unit. So this protocol data unit is sent to the data link layer. So here in the data link layer, the Ethernet address is added. It is nothing but the here it is the Ethernet in the Ethernet, by using the Ethernet cable. Here the Ethernet will have the device address will be there. So the device address is added here for this one. So internet with the whatever the message is sent, it should have the IP address, then physical address, or the MAC address we will call, or the machine address, device address we will call. So that is added here. So Ethernet address, internet protocol address, TCP, transmission control protocol, then HTTP, hypertext transfer protocol, and a request is sent in this way. So when the request is sent, that message, whatever the message is there in the physical layer, whatever the data is there, say in the form of protocol data unit. So all these protocols are added in each and every layer. That is all these protocols are added. So Ethernet in the data link layer, and then the IPI is from the network layer, and TCP in the transport layer, and then HTTP in the application layer, and it is a request is sent here. A request is in the form of these protocols. It is accompanied with all these protocols. So when these many details are added in each and every layer, so it is sent to the physical layer. In the physical layer, This data is converted into the form of signals. This the signal is sent in the form of the data is sent in the form of a signal via the transmission media. Transmission media may be wire or wireless. Wire will be there, or else wire through Wi-Fi it may be sent, or through internet it is sent. So that is this is the transmission channel. Through the transmission channel at the receiver end, even in receiver end, we call it as another node or another host will be there. So that will have another, again it has the different layers are there. So in the physical layer, whatever the signal is there, ones and zeros form, the signal is converted in the whatever the signal is there in the data link layer. They see whatever the signal is there, that is sent back, and then the all process is done according to the protocols in each and every layer. And then at the receiver section, the all the receiver will reply for the receiver will receive the request. So this is the sending end and the receiver end, how the layers are performed. So in the TCP IP network access layer, what happens is it is a network access layer. So it will exchange the data between end-to-end system, and then it is the exchange of data will takes place between the end system and the network. And the address of host and destination will be added. Then the priority TCP the network access the services of the TCP network access layer is there will be a exchange of data between system and network. Then the address of host and destination will be added, and the prioritization of the transmission. That means sequencing of the data. Which suppose maybe which data has to send more, which packet has to be sent in sequence number. So that gives the priority of that particular transmission. Then software at this layer depends on network. So whatever the software we are using it in that one, this will depend on the network. So the network example is a X 2.5 versus the Ethernet. So this one is the software example. This is what the Ethernet. Then segregation means that no other software needs to be concerned about net specifications. So here no software needs to be concerned here. So all these are they are segregation means the separation of this one. This means that there is no other software which needs to be concerned about these specifics. Internet layer. Internet layer is an interconnection of two or more networks. So internet layer, it will handle tasks similar to the network access layer. This internet layer purpose of the internet layer is it will handle the task which is similar to network access layer, but between networks rather than between the nodes on a network. So what it does is the internet layer, it is between the networks, and it is not between the nodes of a network. It is not from the sender to the receiver. It is between the networks. That is the uses of IP for addressing and routing across networks. Mm, So what the purpose of IP is for addressing, and then routing. Routing means sending of the packets from one place to the another place. So uses of IP for the use of IP is internet protocol addressing. It is used for addressing and also routing across the networks. Routing of packets between the networks. Implemented in workstations and routers. So the internet layer is the purpose of this is the services is in it is in workstations and routers also. TCP IP transport layer, what is this is also called as host to host layer. So what is this TCP IP transport layer? Is a reliable exchange of data between applications. They use TCP protocols for transmission. Here, as the name implies, it uses the TCP transmission control protocol for transmission of the packets from one host to the another host. By using this application, it is a reliable exchange of data will takes place by using TCP IP protocol. So for another one is the TCP IP application layer. Here, logic is needed to support variety of applications. So here actually there will be a logic. Logic should be required to support variety of applications. So we require a logic. That means a software is used to support this variety of applications. Separate module supports each type of application. What is that one? This for everything there will be a logical separation will be there. That's how each module supports each type of application. Suppose let us take the file transfer application. If for the file transfer application, the protocols used as FTP file transfer protocol, HTTP hypertext transmission, hypertext transport protocol, telnet telecommunication network, news, simple message transfer protocol. All these protocols are used for transferring of the files. So here the TCP as a four layer, it is discussed. So previous classes we have discussed TCP IP has a four layer, that is data link and physical. All these physical layer and the link layer, data link layer are merged together and it is called a link layer, or else you can say data link physical layer, data link layer. So this data link layer, it is confined to different protocols, that is the Ethernet, token bus, token ring. All these comes under the link layer protocol. Token bus and token ring are the link layer protocols, which we will study in the next modules. So then FDI, FTDI also we will study in the next classes. So these protocols are all these are in the data link physical layer. Network layer, we have IARP, internet protocols are there. What IARP means address resolution protocol. Here in the network layer, we have IGMP and ICMP protocols are also there. Internet control message protocol, internet gateway message protocol. Then the another transport in the transport protocol we have RTP, RTCP, transmission control protocols are there. Then another one, the user datagram protocols are there. OSPF protocols are there. In the application presentation and session layer, they are merged together as application layer, session layer, and presentation layers are merged together. So in this one, Telnet, FTP, SMTP, DNS, SNMP, DHCP, all these are protocols which comes under the RIP also. So these comes under the application, presentation and session layer of the TCP IP protocol suite. So this what is TCP and UDP? These most TCP applications they use the TCP for transport protocol. Then for the transmission layer, the protocol used is the TCP transmission control protocol. So this provides a connection. What is the meaning of connection here? Is it is a logical association between two entities to regulate flow check errors. So to check the flow errors, these are the virtual connections between the two entities. So this one, two entities means two networks. So UDP is nothing but a user datagram protocol. It will not maintain any connection. No connection will be there. This is connectionless service, and TCP service is transmission control protocol. So connection oriented connection. Here connection means logical connection, and here it is a connection, and this is a wireless connection, and therefore does not guarantee delivery. So as there is no Wi-Fi, through Wi-Fi it is connected, that is wireless connection is there, and so therefore there is no guarantee of the delivery of the packets. then there is no preservation of the sequences also we cannot identify, or that means the access of data will take place, or protection against duplication. Suppose there is no guarantee of the protection against duplication. So suppose packets are sent, means we will not be able to recognize it. These are the services of TCP and UDP. So, what is internetworking? Interconnected networks usually implies TCP IP. It can appear to users as a single large network. So, they are all internetworking, means they are all interconnected, one among the other. They are connected. This and usually they supposed to be TCP IP protocol, but it will appear to the users as a single large network. The global internet is the largest example, but intranets and extranets are also examples. So we can say the global internet is the largest example, largest network we can say, but intranets and extranets are also examples of the internet network. So internet working, let us, this is a pictorially represented internet network. A WAN is connected with the help of these switches. All these WANs are connected via wide area networks through the Ethernet cable. Through the Ethernet cable, the all these are connected. So physical connections are available here, as you see here. These are the lines given. These are the physical connections here by using this one. Then token ring, as we have studied the ring format, it will circular format is the topology will be there in the circular fashion. So here all these are nodes, so all nodes are connected in the circular fashion. Through the switches, these are interconnected. So hence, as these are all different, this is FTDI. FTDI is connected with different nodes 1, 2, 3, 4. So all these with the help of the switches, it is connected. So all these networks, total different networks are connected wired. All these wired, wireless, all these things are connected with they are interconnected. They are connected to each other. So hence it is internetworking. So TCP segment, whatever is the TCP transmission control protocol segment, that is nothing but TCP PDU means protocol data unit. So a data unit consists of these many details. As you see here, it will have the source port. So which may be around 16 bits, 16 bits will be there. Destination port address will be there. Each packet or each protocol data unit consists of source port, destination port of 16 bits, sequence number of 32 bits, acknowledgement number as 32 bits, data offset 4 bits, reserved, some reserved bits is there, that reserved bits, that is some 6 bits will be used for reservation, and then flag for the 6 bits flags will be there. URG, acknowledgement, push, reset, sync, finish, all these things for this one 6 bits is assigned. And then window, for window 16 bit will be there. Checksum 16 bits. Urgent pointer 16 bits will be there. Any options is variable. So the size of the TCP header is 192 bits. 192 divided by it is in the form of bits. If you want it in bytes, 1 byte is equal to 8 bits. So 92 bits, the 92 divided by 8. So you will get the 24 bytes of so the protocol data unit size of the TCP header is the header means some extra information is added to the segment or the data. Extra information is added not to lose the information. So this 124 byte, it is the size of the TCP header. So with this, we come to the end of the OSI versus the TCP IP protocol suit. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.